Hello everyone, welcome back. Today let's dive into another medium level problem on Leetcode, House Robber 2, Leetcode 213. We have already solved the part 1 of this problem, which was House Robber 1. I highly recommend solving House Robber 1 first, as this problem is very similar and we will be reusing the solution from that one. Also, this problem is part of Blind 75, a curated list of essential coding interview questions. You can find the full list linked in the description below. Be sure to check it out. Now to the problem. In this problem, we are working as a professional robber planning to rob the houses along a street. Each house has a certain amount of money stashed. All houses at this place are arranged in a circle. That means the first house is the neighbor of the last one. Meanwhile, adjacent houses have a security system connected and it will automatically contact the police if two adjacent houses were broken into on the same night. So our goal is that given an integer array nums representing the amount of money of each house, we should return the maximum amount of money that we can rob tonight without alerting the police. Then in example 1, for the given nums array, we have houses in circle with the amounts 2, 3 and 2. Now, if we rob house 0, we cannot rob house 1 and 2 as these houses are adjacent to house 0. Similarly, if we rob house 1, we cannot rob house 0 or 2. And the maximum amount we can rob will be from house 1, which will give us the amount equal to 3. Similarly, in example 2, for the given nums array, we have houses in circle with amounts 1, 2, 3 and 1. And now the maximum loot we can make is by looting the house 0 and then house 2 with a total loot equal to 4. Hence, we will return 4 as our answer. Now in terms of solution, first let's briefly recap how we solve House Robber 1 using the example and then we proceed to House Robber 2. In House Robber 1, we use the bottom-up dynamic programming approach where we started with the first house, that is with I equal to 0, and we simply check what is the maximum loot we can rob up to this point. And here the answer is 2 because we have only one house to rob from. So we don't have to worry about any constraints and simply rob the amount from that house. And then we include the next house. And again we have to find the maximum amount we can rob, but this time from first two houses. And since we have to maximize the loot, we will take the maximum rob we can have from these two houses. So we have to choose maximum of 2 and 3, which will be 3 in this case. And again move the iterator forward. And now we have to evaluate the entire array. And for the house number 2, we have two choices. Whether to rob it and take its amount 2. That means we cannot rob house number 1. But we can still collect the loot from the non-adjacent houses, which is dp of 0 here with the loot equal to 2. Or we can skip robbing house number 2 and collect the maximum loot up to its previous house, which is dp of 1 equal to 3. And again to maximize the loot, we have to take maximum of the two choices, that is maximum of 4 and 3, which will result in 4. And now since we are calculating the maximum loot for the entire array, this will be our answer. Now let's look at House Robber 2 and see how things change with the circular arrangement. In House Robber 1, we can rob from house 0 and house 2 to maximize the loot, giving a total of 4. But now we cannot rob both house 0 and 2 together because they are adjacent to each other in the circular arrangement. So if I rob house 2, I cannot rob house 0. Or if I rob house 0, I cannot rob house 2. And generically speaking, in the circular configuration, robbing the first house means we cannot rob the last house. Or if we are robbing the last house, we cannot rob the first house. With this additional constraint, now let's explore how we can reuse the solution from House Robber 1. Let's say we have a helper function from House Robber 1 and then we can break the current problem House Robber 2 into two subproblems where we can run this helper function on the entire array excluding the last element. So in this case we will consider the houses from index 0 to n-2 where n is number of houses. So for this subproblem we will get the maximum loot of 3. Next, for subproblem 2, we can run the House Robber 1 helper function on the array excluding the first house. That is, consider houses from index 1 to n minus 1, and the maximum loot from this subproblem range will also be 3. So by breaking this problem into two subproblems, we handle the circular constraint efficiently. So if we rob house 0 in subproblem 1, we exclude the last house, ensuring both of them are not robbed together. Similarly, if we rob the last house in the subproblem 2, house 0 is excluded, preventing any overlap. And again, to maximize the loot, we will take maximum of the results from the two subproblems, which here will lead to 3. Here, this array was symmetrical, so the two subproblems yield the same result. But if the array were different, like this one, then in that case we would have got the maximum loot of 3 from subproblem 1 and maximum loot of 4 from subproblem 2. So our final answer would be maximum of 3 and 4 equal to 4. Now in terms of time complexity, the helper function for house robber 1 will run in O of n time, and in house robber 2 we are calling it twice. So time complexity of this approach will be O of 2n equal to O of n, and the space complexity will be O of 1 if we are using space efficient DP approach from house robber 1. Here is a quick code walkthrough of the algorithm we just talked about, with Java code on left and Python on right. First, let's look at the helper function that computes the maximum loot for a linear sequence of houses starting from start index to end index. Here we use two variables, previous one and previous two, for space efficient dynamic programming, where previous two tracks the maximum loot up to two houses before the current house, and previous one tracks the maximum loot up to the previous house. Now, for every house in the range start and end, we calculate the maximum possible loot up to the current house I. So for each house, we have two choices. Either we rob the current house and take its amount nums I and add the loot collected from the non-adjacent houses stored in previous two, or we skip the current house and take the maximum loot obtained up to the previous house stored in previous one. And to maximize the loot, we will collect maximum of the loot obtained from both the choices and update the previous two to previous one and previous one to current. And once we are done with all the houses in the given range, previous one will hold the maximum loot obtained from the houses in the given range start to end, which we will return to the calling function. Now once we have this helper function defined, we can rob the houses arranged in a circle. To handle this, we will break the circle into two linear subproblems. Subproblem 1 can be that we rob the houses from index 0 to n minus 2, that is starting from first house to second to last house, excluding the last house. Or subproblem 2 can be we rob houses from index 1 to n minus 1, that is from second house to last house, excluding the first house, and maximum value obtained from these two subproblems will be our answer. But we have to still handle one more case, when there is only one house with n is equal to 1. In this case, neither of the subproblems can work meaningfully, because for n is equal to 1, subproblem 1 excludes the last or only house, leaving no range to process. Similarly, subproblem 2 excludes the first and only house, again leaving no range to process. So we handle this case explicitly, where we simply return the value of the single house as the answer, because that is the only house we can rob from. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.